Hey everybody, how you doing? Welcome to What Up Plays channel. We talk about all kinds of things, how to fix, build, maintain, and product reviews. Today, we're going to be putting the Hobbywing V10G4-R. This is the newest version of the Hobbywing XE run motor. We're going to be putting this on the Jerry. We're going to see how this thing compares to the other motors that I'll be testing here. And yeah, so let's go learn something. So the motor I have here, as I mentioned, is the Hobbywing V10G4-R. Actually runs 17.5T. This is hands down the most popular video that I have done a motor on. So as you know, I ran this motor, I tuned it, ran through some other tests, the load master and stuff like that. And yeah, this right here is the most popular video I made on motors. This one has more views than any other motor that I've tested, which are at least a half a dozen or so in the past year. We're going to run this on the Jerry, see how this thing does, see where the power drops off at, see if it is a motor that puts out high RPM but low torque, or vice versa. Anyhow, let's get this hooked up. I'm going to first start off with a free spinning. I'm not going to put any load on it. I'm just going to put the gear on it so that I can test the RPMs using the RPM meter. And after that, I'll run through the whole mess of gears here. I have the 27, 28, 29, 30, 31, 32 pinion gear. I'm going to run it on the load master motor here. The motor that I'm using here is the Surpass V6 17.5. This is the fat boy. It's not the lightweight. The pinion gear, it's actually going to be a spur gear now. This right here is a 31 tooth gear on here, the same one I'm going to use with all the motors I'm going to be testing. And as you can see here, it is hooked up to resistors, so it will supply a load. Alright, let's see how this motor does. Let's get her inside the Jerry and get it set up. Okay, we have the Hobbywing G4-R mounted in the Jerry. As you can see, there's no load motor here. It's just the pinion gear on there that I use for the tachometer reader here. So let's go ahead and test it, see what the amp draw is without a load. Alright, the amp draw, I don't know if you see it there, is 5.74, 3340 kilohertz, or kilohertz, kV. Timing is set at 50.5. Just going to check the RPMs on it, run it for 20 seconds, and see what the see what the RPMs are on it, as well as the temperature when it's done after the 20-second run. Alright, a couple seconds over the 20 seconds, but no harm. And let's see, we got 25,196 RPMs on that. So let's go ahead and check the temperature. Temperature, as you can see there, is 96. Where's it? There it is. 95.2. Okay, now let's go ahead and put the load motor in there, and then we'll start off the 27 tooth pinion and test it. First up, 27 tooth. Let's start it off with the auto test. .46 amps. I don't know if you see that on there. 3057 kV. And I don't know if you guys want to see this right here. The numbers back here are really good. It's a pretty well built motor. But let's go ahead and do the manual and see what the RPMs are. Run it for 20 seconds. Okay, it doesn't say on here, I actually turned it off, but it was 20,500 RPMs. So, let's go ahead and, you can see here, 20,495 RPMs. And we have a temperature is 103. Let's see here. Yeah, it's about 103. All right. Let's kick it up a tooth. Let's take it to the 28 tooth. Okay, Hobbywing G4-R 17.5 with a 28 tooth pinion on it. We're going to do an auto test. Okay, 12 amp, kV is 3027, and both times 50. Now you notice that last little test there, I had to give it a little kickstart. That means the torque on this thing was not the greatest at lower RPMs. So, but if you give a lot of juice, yeah, I'll kick on. But let's go ahead and test the manual RPMs, see what the RPMs is on this thing. Oops, gotta send it a throttle. Okay, we're gonna run it for 20 seconds. Okay, 20 seconds. RPM was 21,322. Let's go ahead and check the temperature on this thing. I bet it's going to be hot. Let's see here. 107. About 107 degrees. Alright. Let's go ahead and put the 29 tooth on. Okay, 29 tooth pinion. I'm sure I'm going to have to give it a little kick again on this one on the last test, just like the last one. But we shall find out. Let's do an auto. Okay, 12.26 kV is 3022. Again, you saw that I had to give it a little kick to do that last test. Let's go ahead and do a manual run, do the 20-second run. And let's start. Okay, 21,881. I don't know, remember exactly what it was last time, but that's not a whole lot faster than the last round. But let's move up. Now we'll go to the 30 tooth. We're halfway done, guys. But before we do that, I almost forgot. We have to check the temperature. 110, 111. So 111 degrees. That's a big jump. Okay, bump to the 30. 30 tooth is now loaded on the Hobbywing. Let's go ahead and kick the auto test. .9, 2952, and if you notice, I did not have to kick start it. I don't know what happened there, but apparently this thing decided it wanted to start running. So let's go ahead and do the manual RPM run and see what the RPMs we get out of it. 20 seconds. Get my clock here set. And let's go. Okay, 22,151, and let's check the temperature on that. Okay, the temperature is about 114, 115. 115. Okay, let's go ahead and try gear 31. Okay. 31 tooth on deck right here. Let's go ahead and do the auto test first. Uh, 12.83 amps and 2997 on the kV. That's pretty strange. It's drawn less amperage with a bigger pinion. You see that? Because last time it was almost 14 amps. Now it's just under 13. But yeah, let's go ahead and see what the amperage is, or not the amperage, but the RPM range is on manual mode. Run a 20-second timer. Here we go. Okay, RPM shot up too. They went to 23,314. Check the temperature. So if that's running less amperage, I bet the temp is going to be less than the last one too. It's about the same, 116 and some change, almost 117. Very strange. Now, some of you might be saying it might be the gear gapping. I use the same gear gapping as always. I use the cellophane trick. Put a piece of cellophane between the gears and bring them together and tighten them down. Alright, let's go ahead and do the 32 tooth. That's the last one. We have the 32 tooth pinion on here now. Let's do the auto mode. Okay, at 13.39 amps, 2,978 kV. Let's do the manual 20-second run, get the RPMs on this thing, and then the temperature. Okay. The RPM on it was 23,876. 23,876. Now some of you might look on here and see the RPMs on this and say, hey, these run here were lower. Well, that's because I have a bigger pinion on here, which is going to spin this gear right here faster than what this is really going, because 32 tooth, 31 tooth. Alright, let's go ahead and take the temperature. Ooh, that's warm. About 116. So it hasn't really changed much, which would make sense because the current draw on this thing was only 13.5 amps, which isn't much more than what it was doing with the smaller gear. So, alright, let's go ahead and put all the numbers together, and then we'll go over it and see what we have. Okay, here's the numbers here from the Hobbywing, so we can compare it with the Tekin. Now, here's my disclaimer. There's tens of thousands of racers out there, so there's going to be tens of thousands of different opinions on what these numbers mean. These are just, what I'm going over here is just my opinion. If you have a different opinion, please share your knowledge. We would all love to hear it, and so we can also make different decisions on them. So with these numbers, you know, putting them on the Jerry really explains a lot about the differences on these motors and how they operate. One thing you look at here is that 27 tooth pinion, 18,561, 20,495. So that's about 2,000 RPM difference. But you look at the amp draw. The amp draw is 1055 versus 1146. The temperatures are about the same, which you'll see a high temp at high speeds with a motor with a very strong rotor in it, which the Tekin has. It has a stronger rotor than the Hobbywing. Now, but when you start to look, you see the amp draw of the Tekin versus the amp draw of the Hobbywing. At 32 teeth, the Tekin's at 12.18, where the Hobbywing is 13.39. But the Hobbywing is spinning at 2,000 RPMs more. So, as I mentioned before with the load master and load motor, the faster you turn this motor, the higher the load. So, the Hobbywing is under a higher load right here. So let's try to compare when they're under the same load. We have the Tekin right here with a 30 tooth is 20,494. The Hobbywing with 27 tooth, which is a 3 teeth difference, is roughly almost the same exact RPMs. It's 20,495. It's 1 RPM different. So they're basically have the same load. The Tekin is 1126 amps, 11.26 amps, where the Hobbywing is 11.46 amps. So it's a 0.2 amp difference. Now, then you have the temperature difference is 103 versus 114. Keep in mind here that the Hobbywing, this is only after 1 run or 2 runs for the Hobbywing, where the Tekin went through 1, 2, 3, 4 or 5 runs. So the Tekin's been through a lot more runs than the Hobbywing. So that's one thing keep in mind. Also, the Hobbywing has a built-in internal fan. So is that the reason why the Hobbywing has cooler temps? I would say absolutely, because there more air is flowing through there and circulating through there to help cool it down. Where the Tekin didn't have any fans on it. When you're out there racing, you're gonna have a fan on it. But let's jump on. So when you look at other instances where you look at the 32 teeth, when the Tekin has 32 tooth pinion, 1218 is the amp draw, 21,767. If you look at 1218 over here, it's going to be between the 28 and the 29. If you work out the numbers, work these out, 1218, the Tekin is still going to be a couple hundred RPMs faster than the Hobbywing. So, but then you have here where the temperatures are also lower than this, but then the Tekin had more runs. But you also see where the current starts to spike, except for right here, it drops down to 12.83. Where would this be at 12.83? I don't know. I don't know if it's going to be, it's going to bump up another, probably go up another tooth, which would only give you probably 1,000. So this one right here would be faster. The Hobbywing would be faster at that point. So, which motor is better? If I had to choose between these two motors, it would depend on the track. If I was on a short technical track, high traction, something like carpet, off-road, you know, I need to have the torque to get out of the corners, get off the jumps and stuff like that, I would go with the Tekin. It's shown to have more low end torque, low end power, and but if I was to go with a track that was open, like an on-road track or something like that, I would go with the Hobbywing motor. Yeah, open track, off-road, you know, clay track, something like that. I do use the Hobbywing. Give a higher top speed, but that's my opinion. If you have a different opinion, by all means, share it with us. Share the knowledge. Let us also know why you get to a certain temperature and it seems like a motor runs more efficient. If you look here, it goes to 1226 between the 29 tooth and the 30 tooth and 31 tooth. The current goes up and then it drops. Same thing over here with the Tekin. The current goes up 11.38, then it drops. It's a lot more elaborate on the Hobbywing than the Tekin, but still, it happens. But anyhow, if this video was helpful, by all means, hit the like button and please subscribe. If you do that, it greatly benefits the channel because it allows me to be able to obtain more motors and do more testings. I do have to purchase all these motors out of my own pocket. Nobody, no companies or anything like that donate them, so it can get pricey when you're looking at motors now, or the average motor is about 120, 130, and they go all the way up to 170 each. Anyhow, yeah, if this video was helpful, hit the like and subscribe. If it wasn't helpful, hit the like and subscribe anyway, just so you can look at all my videos and make fun of me. All right, everybody, you take care.